Hi class, today we're going to talk about molar mass practice. So we can see in our problem here that we're given 67.89 grams of copper. And what we want to do is we want to convert that to a number of moles. So we're going to start off with our given value. Our given value generally goes in the top left corner. So we have a 67.89. And what we're going to do is we're going to multiply that by some conversion factor. Our conversion factor is going to be our molar mass. So it's the mass per mole of something that I have. And I have to be, remind myself that the thing that I want to convert to goes on top. So in 1 mole of copper, I need its molar mass. So I can find its molar mass on the periodic table. If I look at the periodic table, I can see that copper has a molar mass of 63.55 grams. So that's how many moles, that's how many grams are in 1 mole of copper, this many grams. That also means that this many grams of copper is equal to Avogadro's number worth of copper. And so what I should see is that grams are going to cancel out here, grams of copper, and I'm left with moles of copper. And so when I plug this into my calculator, what I get is 1.068 moles of copper. So just so you're aware, I can abbreviate mole to MOL, and this is of copper. And your way of checking to see if this answer is reasonable is you're going to compare your given mass to your molar mass. Again, your molar mass you can find on the periodic table, and 67.89 is greater than 63.55. So I would expect to have more than 1 mole of copper, and in this case I do. So let's move along to the next. There we go. And here's our next question. How many moles are there in 19.10 grams of iron oxide? So how could I figure out how many grams there are in iron oxide? What's its molar mass? And the answer is that we'll just take the molar mass of iron and the molar mass of oxygen and add them together. So I have this many grams of iron oxide, and what I want to figure out is this how many moles there are here. And the reason why I care about this is because I don't have a balance for moles. But reactions don't happen based on grams. They happen based on the number of atoms or molecules. So if you remember back to our cooking example or recipe, we generally don't make a recipe based on how many grams of something I have. We usually do it based on how many of this and how many of that I have. And in this case, this and that refers to moles. So 1 iron mole and 1 oxygen mole will give me 1 mole of iron oxide, but I can't say that 1 gram of iron and 1 gram of oxygen will give me 2 grams of iron oxide. It doesn't work that way exactly. So again, I want moles, so I'm going to put 1 mole on the top, and then on the bottom I'm going to add the masses of iron, which is 55.85 grams, and I'm going to add that to the mass of oxygen. And oxygen, if you look on the periodic table, it says 16. So I'm going to add that 16 grams per mole of oxygen. And so when I add these two numbers together, I'm going to get 71.85 grams. So I'm going to end up dividing by 71.85 grams. And this is for FeO. Okay, so all I did was add those two things together. And if I have more atoms, I can just add all of those together. And I'm just going to add up their masses on the periodic table. So when I divide 19.10 grams by 71.85, my grams of iron oxide cancel out. And then what I'm left with is moles. And then I'm going to get 0.2453 moles of iron oxide. And again, I can abbreviate mole to MOL. This is of FeO. So here's a little trick to check to see if you did this right or not. So you're going to compare your given mass with your molar mass of the thing that you want to find. And if you see that the given mass is smaller than the molar mass, and you should expect to have less than 1 mole. If you have more, if your given mass is higher than your molar mass for whatever you're looking at, you should expect to have more than 1 mole. So that's a quick little check that you can do to see if you're on the right track. So let's try the next one out. How many grams are in 5.3 moles of lithium? So we're going to do the opposite this time. We're given moles. So I have 5.30 moles of lithium. And this time, instead of dividing by the molar mass, I want to multiply by the molar mass. So when I do this, 5.3 moles of lithium, I'm going to multiply this time because I'm just multiplying or dividing by the molar mass. So in this case, I'm multiplying. When I look on the periodic table for lithium, my molar mass is 6.94 grams per mole. So that's exactly what I'm going to write down, 6.94 grams of lithium in 1 mole of lithium. And again, the thing that allows me to do this is just the fact that 6.94 grams is equal to 1 mole of lithium. So I'm really just multiplying by 1. My moles are going to cancel out. And then what I'm going to be left with is 5.30 times 6.94, which gives me 36.8 grams of lithium. And what I should be asking myself is this answer reasonable? And the answer is that yes, it is reasonable. And the reason why it's reasonable is because I have more than 1 mole, so I should expect this to be roughly 5 times the molar mass of lithium, which it is, give or take. So let's try the next one out. How many grams are there in 0.0089 moles of lead? And this is, in this case, lead 4 oxide. So in this case, again, I'm gonna do the same thing. I'm gonna start off with my moles of lead 4 oxide, and so I'm just gonna write down my given value on the top left corner. And this time I'm gonna have to figure out the molar mass of lead oxide. So that's what I'm gonna try and do here in a second. I have to get my periodic table to do this. And what I'm going to do is I'm going to multiply by the molar mass instead of divide. So in 1 mole of PbO2, 1 mole of PbO2, I have to look up the molar mass of lead, and I have to look up the molar mass of oxygen, and I need the mass of 2 oxygen. So when I look at my periodic table, I can see that the molar mass of lead is 207.2 grams per mole. And then when I look at the molar mass of oxygen, I get 16, but I have to remember that I have 2 of them. So I'm adding 2 times 16, or 32, and it's 0.00. In this case, the zeros won't affect the number at all. But what I'll end up with is a number like 239.2. So that's the molar mass for lead 4 oxide, 239.2 grams in 1 mole. And the reason why this number is so high is really just because lead is so heavy. Lead by itself is 207.2, so when I add the oxygen in there, I get a much larger mass. And so when I multiply these 2 numbers across, and I divide across the bottom, my moles of lead oxide cancel out, and what I get is 2.1 grams of lead 4 oxide. So you might be thinking, well, this is based on how large the mass is or how small the number of moles are. You would maybe expect the number to be bigger or smaller. But if I think about it, this is a small number, this is a fairly large number. So when I multiply a small number and a large number, I get a reasonable number. So if I were to look at this amount of stuff, I would say this is a really small amount of stuff. But think about how dense it is. Like the molar mass is essentially how dense something is. So the lighter it is, the less dense it'll be. The heavier it is, the more dense it'll be. So if I have a little piece of lead and a lot of hydrogen, let's say, a little piece of lead might weigh more. And again, that's just based on the molar mass. So hopefully this helps. Good luck on the next one. See you next time.